Are you prepared for a visual ensemble of infinite wonders? Each picture serves as a window to the universe, revealing divine secrets hidden thousands of light years away. Here, we encounter mysterious galaxies, fiery nebulae, and stunning star clusters, each with a tale to tell. But what lights the ethereal glow of these distant objects? How do they shape the universe we know today, and what unknown secrets are they still waiting to disclose? Come, let's embark on an interstellar odyssey, gazing into the fabric of the universe through the eyes of the Webb telescope. Prepare to be captivated. Let's go! Number 1. Enceladus Plume, Webb's NR spec and Cassini image. Let's set out on an interplanetary journey to our first destination, the Enceladus Plume, seen through two striking lenses, the Webb's near-infrared spectrograph, NR spec, and the Cassini orbiter. Imagine a screen unveiling a spectacle from the James Webb Space Telescope's NR spec. On this vast stage, a water vapor plume astonishingly springs from the southern pole of Saturn's moon Enceladus. This plume is no small spray. It extends dramatically over 20 times the size of the moon itself. A sight to behold, wouldn't you agree? Embedded within this scene is an inset image from the Cassini orbiter, contrasting the tiny Enceladus against its colossal water plume. This comparison highlights the remarkable scale of the phenomenon unfolding before our eyes. Quite a perspective, isn't it? Thanks to the James Webb Space Telescope, scientists can now directly observe how this fantastic plume sustains the water cycle of Saturn and its ring system. Isn't it amazing how a moon smaller than Earth can hydrate a giant planetary system? After analyzing the data from Webb, astronomers discovered an intriguing distribution. About 30% of the water remains inside a torus, or a fluffy, donut-shaped cloud of water, co-located with Saturn's E-ring. The rest, a generous 70%, escapes to sustain the wider Saturnian system. Let's take a closer look at Enceladus, a moon just 4% the size of Earth and only 313 miles across. Despite its size, it's a hub of scientific interest. Because Enceladus is an ocean world, with a vast reservoir of salty water hidden beneath its icy outer shell. But there's more to it than just an ocean. The moon boasts geyser-like volcanoes that eject jets of ice particles, water vapor, and organic chemicals from cracks on the surface, casually called tiger stripes. Could these elements hold the potential for life as we know it? That's the tantalizing question that makes Enceladus one of the most exciting scientific targets in our solar system in the quest for extraterrestrial life. Fascinated by this cosmic detective story? Number 2. NGC 346 NM image. Are you ready for a cosmic journey to NGC 346? Let's dive into the mysteries of this dynamic star cluster nestled within a cloud an astounding 200,000 light-years away. Our guide for this trip is none other than NASA's James Webb Space Telescope, equipped with its near-infrared camera, to capture breathtaking views. The telescope's unblinking eye reveals more stellar components than ever thought possible, paving the way for the birth of both stars and possibly even planets. By uncovering dense, dust-filled clouds mingling with abundant hydrogen, the most common element in the universe and the main ingredient for star formation. Within the stunning scene of filaments and arcs, two unique forms of hydrogen appear. But what's the difference between them? The pink gas represents energized hydrogen, dancing with energy and burning as hot as 10,000 degrees Celsius, around 18,000 degrees Fahrenheit, or even hotter. It's enough to melt any metal known to us on Earth. In contrast, the orange gas represents a more stable form of hydrogen. These are dense molecular hydrogen clouds that remain much cooler at around -200 degrees Celsius, -300 degrees Fahrenheit. Packed with dust particles, these chilly gas clouds serve as a fantastic stellar nursery, nurturing new stars. As these stars emerge, they dramatically reshape their surroundings, much like an artist sculpting a masterpiece. The result of this cosmic creativity can be seen in the undulating edges that echo throughout the image. These are the results of young stars breaking apart the dense clouds with their brilliant light. The various pillars of gas glowing with an ethereal sheen further demonstrate this process of stellar erosion. They stand as a testament to the eternal cycle of birth, transformation, and change that governs this distant region of the universe. Can you picture this powerful dance of cosmic forces unfolding over a timescale that spans eons? Quite an incredible vista to contemplate, isn't it? Number 3. NGC 2440, the hottest star known to humanity. NGC 2440 is a well-studied example of a planetary nebula. The term planetary nebula is somewhat misleading, as these celestial objects have nothing to do with planets. They are actually the shells of gas and dust ejected by stars like our Sun in the final stages of their life cycle before becoming white dwarfs. The gas is illuminated by the intense ultraviolet radiation from the hot white dwarf at the center, causing it to glow. In the case of NGC 2440, the central star is one of the hottest white dwarfs known to astronomers, with a surface temperature estimated to be close to 200,000 degrees Celsius, more than 30 times hotter than the surface of our Sun. The nebula surrounding this star has a complex, turbulent structure, suggesting to astronomers that the star has undergone multiple phases of mass loss, each time ejecting material in a different direction. This episodic shedding process is thought to be similar to what happens in other planetary nebulae, such as NGC 2346. NGC 2440 is also known for its rich content of dust. Some of the dust clouds in this nebula form long dark streaks pointing away from the central star, perhaps tracing the paths of past mass ejections. Beyond the glowing gas of the nebula, visible in optical light, there is a larger cloud of cooler gas that can be detected with infrared telescopes. This cooler gas doesn't glow, but it's heated by the hot central star, causing it to emit infrared radiation. Finally, NGC 2440 is located very far from us, about 4,000 light-years away, in the direction of the constellation Puppis. Despite its distance, it's a popular target for amateur astronomers with telescopes due to its bright, complex appearance and fascinating history. Focus on number 4, the fabulous dance of grandiose strips. Enter the heavenly stage, NGC 1566, a cosmic system abiding in the group of stars of Dorado, otherwise called the dolphin fish. Settled a stunning 40 million light-years from our home, this galaxy indeed has a story to tell. NGC 1566 is arranged as a middle twisting galaxy. Now, you might wonder, what does that mean? Picture an excellent pinwheel in the universe. Yet, unlike the classic image of twisting galaxies with a pronounced bar-shaped cluster of stars at their core, or the unbarred spirals with no central bar, NGC 1566 moves to its own beat. It's neither fully barred nor unbarred, an infinite ambiguity that piques the curiosity of cosmologists. At the core of NGC 1566, there's an especially vibrant show. The center of the galaxy, despite its small size, shines with such intense light that it stands out in the image, a trademark quality of a Seyfert galaxy. You might ask, what makes Seyfert galaxies stand out? Well, these galaxies have centers that are intensely active and brilliant, emitting powerful bursts of energy. More intriguingly, these centers may harbor supermassive black holes, their mass overshadowing our Sun by millions of times. Yet NGC 1566 is no ordinary Seyfert galaxy. Among its kind, it's a cosmic superstar, earning the title of the second brightest Seyfert galaxy known to us. Not only that, within the Dorado group, a cluster of galaxies in the southern hemisphere, NGC 1566 is the light of this gathering. Similar to a cosmic archipelago, it's one of the most crowded galaxy clusters of the southern sky. Through this new image captured by Webb, we can appreciate the beauty and unique structure of NGC 1566. It shines like a cosmic beacon, its bright core surrounded by swirling, even arms of lavender shades, resembling strips fluttering in a vast breeze. Can you picture it? This fabulous dance of divine light and color unfurling in the far-off stretches of our universe is a testament to the cosmic spectacle that is the galaxy NGC 1566. NGC 1952. Dive further into the fascinating universe of NGC 1952, or the Crab Nebula, as it's commonly known. From the view of a ground-based telescope, the nebula presents itself as a vivid cosmic painting awash in bright hues, a quiet declaration of a celestial event that occurred over 900 years ago. The story of the Crab Nebula began with a bang, quite literally. It's the stellar remnants of a supernova, the explosive death of a star. A supernova is one of the most energetic events in the universe. When a star explodes, it releases in mere minutes the same energy that our sun would emit over billions of years. When the light of the supernova that created the Crab Nebula reached Earth in the year 1054, it was a remarkable sight. The explosion was so bright that it was visible even during the daytime for weeks. Can you imagine what it must have been like watching an extra star in the daytime sky? The nebula itself is a vast, 10 light-year wide expanse of space. It can be difficult to grasp the enormity of this size, so let's put it into perspective. 1 light-year is the distance that light, the fastest thing in the universe, travels in a year, roughly 6 trillion miles. Multiply that by 10, and you have the staggering size of the Crab Nebula, a celestial structure spanning 60 trillion miles. This cosmic relic lives an impressive 7,000 light-years away from Earth. It is located in the constellation Taurus. This distance means that the light we see today from the Crab Nebula actually began its journey 7,000 years ago, during the Stone Age on Earth. When you observe the Crab Nebula, you'll notice a swirling blend of pink, red, and orange filaments, especially towards the edges of the nebula. These are more than just cosmic colors. They are remnants of the exploded star. These are the layers of gas that were once part of the star, flung into space by the supernova explosion. Each colored filament, each stroke of light, is a fragment of the star's history, now forever on display in our night sky. In the vast expanse of space, the Crab Nebula is a stunning monument to the birth, life, and death of stars. It's a silent storyteller of a star's final journey, a beautiful display of the cyclical nature of our universe. Doesn't this make you wonder what other cosmic stories are waiting to be told in the night sky? NGC 5189. Imagine you're looking through the lens of the James Webb telescope. It reveals the marvel of NGC 5189, a captivating display of cosmic chaos, known as a planetary nebula. Before you get carried away, remember, this doesn't have anything to do with planets. It's about the existence of stars. Inquisitive, isn't it? This divine character is serenely arranged about 1,800 light-years away. However, what does that mean for us, you might inquire? Well, assuming you were traveling at the speed of light, about 186,282 miles per second, it would take you 1,800 years to arrive. Truly an excursion, wouldn't you concur? NGC 5189 possesses an enchanting corner in the constellation Musca in the southern hemisphere. It looks like a parallelogram, which is a square shape that has been tilted, giving it a bit of an incline. However, this is no ordinary math example. It's a haze of gas glowing with the iridescence of 1,000 dreams. Webb captures this cloud in all its brilliance, revealing long ringlets of gas winding through the void and gleaming dust clouds that radiate like jewels against the velvet backdrop of space. Additionally, it shows comet-like clumps of material, all pointing away from the central star as if in deference to its might. A charming sight, isn't it? But beneath its heavenly appeal, NGC 5189 conceals a tantalizing mystery. Its dislocated structure alludes to an extraordinary celestial drama unfolding at its core. Something vibrant and wild likely happened at the heart of this cloud. But what? This question is a conundrum drawing astronomers from around the globe to uncover the secrets of this baffling nebula. Could you resist such a mystery? Number 7. NGC 346. Picture this. A dynamic star cluster nestled within a nebula an astounding 200,000 light-years away. Our guide for this journey is none other than NASA's James Webb Space Telescope, with its near-infrared camera arm capturing stunning views. The telescope's unblinking eye reveals far more celestial details than ever before, potentially preparing for the birth of both stars and even planets. By uncovering thick, dust-filled clouds mingling with abundant hydrogen, the most common element known to humankind and the primary building block for star formation. Inside the breathtaking scene of crests and arcs in this image, two distinct forms of hydrogen emerge. But what's the difference between them? The pink gas represents energized hydrogen, dancing with energy and burning as hot as 10,000 degrees Celsius, about 18,000 degrees Fahrenheit, or even hotter. It's enough to melt any metal known to us on Earth. In contrast, the orange gas represents a more stable type of hydrogen. These are dense molecular hydrogen clouds, which remain much cooler at around -200 degrees Celsius, about -300 degrees Fahrenheit, bundled with dust particles. Despite sounding harshly cold to us, these chilly gas clouds serve as an incredible cosmic nursery, nurturing new stars. As these stars emerge, they dramatically reshape their surroundings, much like an artist sculpting a masterpiece. The result of this cosmic creativity can be seen in the undulating edges that echo throughout the image. These are the effects of young stars piercing the dense clouds with their brilliant light. The various gas pillars, glowing with an ethereal radiance, further showcase this process of celestial erosion. They stand as a testament to the perpetual cycle of birth, change, and transformation that governs this far-off region of the universe. Can you picture this powerful dance of cosmic forces unfolding over a timescale spanning millennia? Quite a stunning vista to behold, isn't it? Number 8. Chameleon Eye Molecular Cloud. This cosmic wonder isn't just any ordinary cloud. It's a dark molecular cloud teeming with potential for celestial life cycles. This fascinating cloud, located a relatively modest 630 light-years from us, is brought to life through the view of NASA's James Webb Space Telescope's near-infrared camera and ArcM. The image shows the heart of Chameleon Eye, where the cool, ethereal cloud material unfolds, illuminated in the infrared spectrum. Captivating, isn't it? One hero of this cosmic tale is the young, energetic protostar named SED-110 IRS-4. The glow from this emerging star in the making paints the upper left corner of the image in shades of orange. Meanwhile, calm stars in the background, appearing as tiny orange specks, help us uncover hidden secrets within the cloud. How, you might ask? The light from these stars plays a crucial role in identifying ices within the cloud. These ices absorb the starlight passing through the cloud, giving us an indirect glimpse into its icy composition. Adding another layer to this interstellar narrative, an international team of astronomers made a remarkable discovery. They detected a mix of different ices residing within the darkest regions of this cold molecular cloud. This discovery not only paves the way for studying simple icy particles destined to be part of future exoplanets, but it also offers an exciting view into the origins of complex molecules. Why is this important? These complex molecules are the precursors in the assembly of life's building blocks. They give us a peek into the cosmic chemistry that might ultimately lead to life, setting the stage for the ever-continuing search for life beyond our planet. Doesn't this offer a tantalizing glimpse into the mysteries of the universe? Number 9. Pillars of Creation from a Different Perspective. Merging the vision of two advanced cameras aboard NASA's James Webb Space Telescope, a breathtaking portrayal of the universe as seen in the infrared spectrum comes to life. It's a cosmic tapestry of Webb's near-infrared and mid-infrared images, illuminating the starry region known as the Pillars of Creation with a wealth of new insights. The scene is dotted with countless stars, painting a near-infrared mural that's the handiwork of Webb's near-infrared camera, film. This light spectrum also brings attention to thousands of newborn stars. Can you see the bright orange orbs nestling outside the dusty pillars? With the mid-infrared instrument MIRI, dust takes the spotlight. Layers of diffuse orange dust are artistically draped across the top of the image, flowing into a striking V formation. The denser regions of this cosmic cloud are veiled in a deep indigo shade, concealing the activities within the pillars from our view. Do you see the tower-like pillars extending from the lower left to the upper right? They're composed primarily of dust, a vital ingredient in the recipe for star birth. When gas and dust coalesce and reach a critical mass within these pillars, gravity takes hold, causing the accumulated material to collapse, heat up, and eventually give birth to a new star. Do you spot the splashes of red woven into the image? They hint at even more embedded stars. These stars, still in their infancy, are bustling with activity. The areas resembling molten lava capture their sporadic outbursts. As these young stars form, They intermittently emit supersonic jets that interact with the surrounding material, such as the gas and dust pillars seen here. These youngster stars, assessed to be 200,000 or 300,000 years of age, will continue to form for a huge number of years. All that you find in this scene is relatively close, infinitely speaking. The far-off universe is darkened both by the interstellar medium, the gas and dust between the stars, and a thick dust path in our Milky Way galaxy. Thus, the stars take the spotlight in Webb's viewpoint of the pillars of creation. The pillars of creation act as a small part of the massive Eagle Nebula, located about 6,500 light-years away. Isn't it captivating how even a small district of our universe can hold such intricacy and interest? Number 10. Wolf-Rayet in a new light. The infinite dust shells around Wolf-Rayet 140 give a brief look into the mysterious domain of binary star systems, which are pairs of stars orbiting a common center of mass. These shells are charming as they resemble the concentric rings found in tree trunks. However, instead of marking long years of growth, these astronomical rings reveal the interaction of the binary stars over their 8-year orbital cycle. This remarkable system contains two stars moving around one another in an unpredictable vast dance. Every 8 years, these celestial companions draw closer together, creating a scene in the form of normal, even dust shells. These shells, like tree rings, display a consistent pattern, signaling the reliable nature of these celestial events. Their regularity serves as a cosmic metronome, marking each cycle of the binary system's dance in the magnificent cosmic scene. Various colors provide changing information about the universe. The picture representing this display features a blend of blue, green, and red shades. These colors were carefully assigned, each representing data collected by Webb's mid-infrared instrument, MIRI, at different microns, 7.7, 15, and 21. The broader context, the infinite dust shells of Wolf-Rayet 140, adds to our understanding of the life patterns of stars, especially those in binary systems. Not only does this system showcase the beautiful synchrony and periodic nature of binary stars, but it also highlights the remarkable phenomena that occur when such stars gravitate toward each other. How interesting is it to imagine the cosmic timing happening millions of miles away from us? Number 11. L1527. James Webb Space Telescope's close-infrared camera, (HIAM), features the protostar nestled inside the shadow of L1527. It's a cosmic nursery where the protostar is surrounded by a material-rich cloud that fuels its growth, much like a caterpillar inside a cocoon. It is nested inside, developing and changing. A powerful scene unfolds around this protostar as it advances. The star emits material, cutting out cavities above and below it. These emission zones cast a hypnotizing display of orange and blue shades in this infrared vista. Do these colors not weave an entrancing cosmic embroidery? In the upper central region, a display arises as bubble-like structures. These are not your ordinary bubbles, but rather the result of celestial burps, much like hiccups. These are irregular emissions from the star, displaying its lively, dynamic nature. Webb's sharp eye also spots fibers composed of molecular hydrogen. But what's so unique about them? These fibers have been shocked by past stellar discharges, bearing evidence of the protostar's memorable journey. The cavities created by the protostar's emissions have captivating shapes. Notice how the edges at the upper left and lower right are straight, while those at the upper right and lower left curve smoothly. It's a stunning display of geometric differences. And what about the region at the lower right that bears a blue tint? It's because there's less dust between it and Webb's observation, unlike the orange areas above, which have significant intervening dust. Isn't it captivating to ponder the dynamic environment in which a protostar grows and evolves, painting a clear cosmic picture as it does so? Number 12. Outer layers of the Einstein rings. The picture before you shows a truly rare scene in our universe. The Galaxy Cluster 0-2-2058 ES, captured by the Webb telescope. It resides in the Fornax constellation, also known as the Furnace, located in the southern hemisphere's night sky. It stands out for its extraordinary shape, bending around its circular companion like an ethereal cosmic snake. What you're looking at is one of the largest and most complete Einstein rings ever found, reflecting its fiery host galaxy. Due to its intriguing appearance, it has been aptly named the liquid ring. But what is an Einstein ring, you may ask? Named after the brilliant physicist Albert Einstein, it's a phenomenon he first theorized in his groundbreaking general theory of relativity. It involves the bending of light due to gravity, a process known as gravitational lensing. Just like a lens can bend and focus light, so can gravity. Now, how does this relate to the fascinating bend of galaxy 0-22058s? The universe we see is actually a background universe, and its light bends around the gravity of a galaxy cluster directly in front of it. The result is the mesmerizing ring-like shape. The central circular galaxy of the cluster aligns perfectly with the background universe, transforming its light into a near-perfect ring. And wait, gravity from other galaxies in the cluster is expected to cause even more interesting distortions. What makes these cosmic wonders so extraordinary? They serve as remarkable cosmic laboratories, allowing us to study galaxies that are too far and faint to be generally visible. Isn't it amazing to think of how much we can learn from these distant cosmic beacons? As we close this cosmic journey, we hope you've been impressed by the stunning visuals and fascinating stories we've explored together from the perspective of the Webb telescope. This is just a brief glimpse into the vastness of our celestial universe. There's so much more to discover, so many more cosmic tales waiting to be told. If you've enjoyed this adventure through the stars and want to delve deeper into the secrets of our universe, remember to hit the like button, tell us what you found most captivating in the comments below, and if you haven't done so yet, hit subscribe to stay connected. On your screen right now is another video packed with fantastic content about the James Webb Space Telescope. Click on it for more cosmic exploration. Remember, each click brings you one step closer to the mysteries of our universe. Thank you for joining us on this journey, and as always, keep looking up. The universe has so much more to show you.